Okay, good day. This is Math 140 College Algebra. I'm Professor McCulley, and this is lesson 3.4, the quadratic formula. So let's get to it. Today we're going to use completing the square to derive the quadratic formula. We're going to solve quadratic equations using the quadratic formula, and we're going to use the discriminant to determine the number and type of solutions to a quadratic equation. So just a quick review of the last lesson. Completing the square. If you're given a equation, a quadratic equation in this form, ax squared plus bx plus c, we can use this process to solve for x. We're going to move the constants to the right hand side, divide both sides by a, add b over 2 squared to both sides of the equation. We'll complete the square into a perfect square binomial, and then we'll solve for x using the principle of square roots. That's pretty straightforward. So somebody long time ago, smarter than me, said I have to do a bunch of solving quadratic equations and I don't want to complete the square anymore. So what happens if I take this generalized formula without a, b, and c being known quantities and I just complete the square on that? And what happens is we get the quadratic formula out of that. And that's how a lot of formulas are derived. They take a general form and they do something to it and they make it useful to them, especially if they have to plug in repeatedly. So we're going to follow the steps. And the first step, if you remember, was to move the constant to the right. And so I'll get ax squared plus bx equaling to negative c. So I got to subtract c from both sides. And I don't know what a is, so I got to assume it's not 1. So we're going to divide by a. That'll give me, if I divide ax squared by a, I'll get x squared. Bx divided by a is b over ax. And then negative c divided by a is negative c over a. All right, and so in this case, we're going to add b over 2, but b is actually b over a. And so if I divide b over a by 2, I'm going to get b over 2a. And if you need me to show that, I can do it in class. So I'm going to add b over 2a squared to both sides. And that gives me a perfect square on the left-hand side. X squared plus b over 2ax plus, oops, I don't need 2a there, I just need a there. Oops. Don't do that, don't do that. Not responding. Undo. There we go. I just want to erase. It's just b over a, and then add b over 2a squared equaling to negative c over a plus b over 2a. Let's do a better job. Over a plus b over 2a quantity squared. All right, and so we're going to complete the square. And so this on the left-hand side becomes x plus b over 2a quantity squared. And then let's simplify this side. I get negative c over a plus b squared is b squared, and then 2a squared, 2a times 2a would be 4a squared. And so now I want to add fractions. And so for the next couple steps, I'm only going to be working on this side, simplifying just a little bit to simplify. Okay? And so what I'm going to go, I need a funky one here. So I'm going to go 4a over 4a times negative c over a plus b squared over 4a squared. And so when I multiply 4a times 4a, I get 4a squared. So now I'll have a common denominator. And so I'll have negative 4ac plus b squared all over 4a squared. And let's clean this up a little bit so that we can read it. It'll be negative 4ac. All right, and so let's reorder. And that will give me b squared minus 4ac all over 4a squared, and that's still equal, we'll just bring all this down, x plus b over 2a quantity squared. So now I'm going to take the square root of both sides. That'll give me x plus b over 2a equals 2 plus or minus the square root of b squared minus 4ac all over 4a squared. Now the numerator is not a perfect square. In fact, we can't do anything with it. So we're going to leave that plus or minus there, and we're going to go b squared minus 4ac, and we're going to leave that on the top. But the denominator is a perfect square. So we can take the square root of that. The square root of 4 clearly is 2, and the square root of a squared is a. And so we have x plus b over 2a, and so we're going to subtract b over 2a from both sides. And luckily for us, 2a and 2a are common denominators, so our final answer, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and this thing, as it is written, is the quadratic formula. And if you don't have that committed to your long-term memory, you really should do that. Alright, so use the quadratic formula to solve some quadratic equations. So in this particular instance, this one I know we could do by factoring, so I'm doing this as an easy one, as an elementary example to show you how to do it. So my value for A is going to be 1, my value for B is going to be negative 4, and my value for C is going to be negative 5. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case I'll have negative 4 is 4 plus or minus the square root of negative 4 squared minus 4 times 1, because a is 1, times negative 5 all over 2 times 1. So we're going to simplify that. 4 plus or minus the square root. 4 squared is 16. Negative 4 times negative 5 is positive 20. Positive 20 and 16 is 36 all over 2. And 36 is a perfect square, so I have 4 plus or minus 6 all over 2. And so our final answer here, what we're going to do is we're going to simplify this. So I can add these two. 4 plus 6 is 10, divided by 2 is 5. 4 minus 6 is negative 2, divided by 2 is negative 1. So my solutions are 5 and negative 1. Now for the second one, we have to do a little bit more because we got to get it into ax squared plus bx plus c form. And so the first thing we're going to do is we're going to subtract 3x from both sides. And that'll give us 2x squared minus 3x minus 8 equals to 0. Now 2 is our a, negative 3 is our b, negative 8 is our c. So when we go to plug in, we'll say x is equal to negative 3 is 3, plus or minus the square root. It'll be negative 3 squared minus 4 times a, which in this case is 2, times c, in this case negative 8, all over 2 times 2. So let's see here, I get 9, there's an 8, there's a negative 8, so negative, so I'll get negative 8 times negative 8 is positive 64. So I have 3 plus or minus the square root. 9 and 64 is going to be 73. And I think 73 is prime. So I actually think, luckily or unluckily, I think this is going to be my final answer, because 73 I can't think of a number that divides 73 evenly off the top of my head. Maybe you guys see it and you can tell me in class or leave me a comment, but I think I'm done there. All right, the last thing for the day, we're talking about the discriminant. The discriminant is a part of, under the radical of the quadratic formula, it's b squared minus 4ac. And so if b squared minus 4ac equals to 0, then the quadratic equation will only have one real solution. If b squared minus 4ac is greater than 0 or positive, then the quadratic equation will have two real zeros. And then if b squared minus 4ac is less than 0, then the quadratic equation will have two imaginary zeros. Now this is kind of a duh moment. And so if we go back to this quadratic formula here, it's under the radical. Plus or minus means the two different values. So when we did this one right here, we went 4 plus 6 divided by 2, and then we went 4 minus 6 divided by 2. So if this number here is positive, then the square root of a positive number is a real solution. You'll have 1, 2 real solutions. If what's underneath here is 0, then we won't have a plus or minus. Plus or minus 0 is just negative b over 2a. That'll still be a real solution, but there'll only be one real solution. If b squared minus 4ac becomes negative, well then I'll have a negative under a radical, so I'll have something that is imaginary. And when I go plus or minus an imaginary, I will have two imaginary zeros. So if I get something like this, and it says use the discriminant to determine the number and type of zeros for the following quadratic equation, I am going to use that b squared minus 4ac. In this particular instance, it's going to be negative 4 quantity squared minus 4 times 3 times negative 7. Oops, didn't copy that right. 3 times negative 7. Where 4 squared is 16. 4 times 3 is 12, and I get the minus. So negative 12 times 7, it's negative 70, and 14, so negative 84. Negative 84, or it's actually be positive 84 because I have a negative times a negative. So this will be 100. So since this is positive, there will be two real solutions. And that is my final answer. Well, that's all I got for today, folks. So, the Marvel fun fact of the day, Thor Ragnarok marked the first time that Mark Ruffalo actually voiced the Hulk. Until that point, the Hulk was voiced by Lou Ferrigno, who is the man who played the character in the 1980s TV show with Bill Bixby. And there's a picture of him back in the 80s. It was one of my favorite TV shows when I was a young lad. That's all I got, folks. Have a good day. Bye.